Continuing with our final exam review problems, we've got some definite integrals to evaluate now. The integral from 1 to e squared of ln of x squared over x. So let's see, what approach do you think we could use here? Ln x and 1 over x are related as one is a derivative of the other. And whenever you see two functions in your integrand where one is a derivative of the other, u substitution is a good thing to try. So we'll do that first. So we're going to let u be ln x, and then du dx would be 1 over x. And then we just solve for the dx. So dx is going to be x times du. And then because this is a definite integral, I also need to change the bounds of integration. So I need to figure out that 1 and e squared, those are x values. So I need to change them to u values. So u of 1 and u of e squared. So u of 1, if I plug a 1 into my formula that I set up for u is the ln of x. So if I plug a 1 in for x, the ln of 1 is 0, and the ln of e squared is 2. So this becomes the integral from 0 to 2 of u squared over x times dx is x times du, and lucky for us, those x's cancel. So this becomes the integral from 0 to 2 of u squared du. The antiderivative of u squared is u cubed over 3. We'll evaluate from 0 to 2. When you plug a 2 in, you get 8/3. And when you plug in a 0, you get 0. So this simplifies to 8/3. The integral from 0 to 5 of x minus 1 over x squared minus 1. We've got a fraction. It's the denominator factors to two linear factors. So I'm going to use partial fractions to break this up. So not doing anything with the integral yet, I am just breaking up the fraction to start. So I want to rewrite this as a over x plus 1 plus b over x minus 1. Multiply both sides of the equation by the common denominator. On the left, the whole denominator cancels and I get x minus 1. And on the right, I get a times x minus 1 plus b times x plus 1 after I cancel. So without even having to do any plugging in of x's, I can see right away that a has to be 1 and b has to be 0. If you replace that a with a 1, 1 times x minus 1 is x minus 1, which is the left side of the equation. So if you make a 1 and b 0, this whole thing is a true equation. So that means I can rewrite this as the integral from 0 to 5. Instead of the given fraction, I'm going to break it into these two fractions, one of which has a numerator of 0, so it just goes away. So this becomes 1 over x plus 1 dx. And then the antiderivative of 1 over x plus 1 is the ln of x plus 1. And we're going to evaluate this from 0 to 5. So when I plug in the 5, I get the ln of 6. When I plug in the 0, I get the ln of 1. But the ln of 1 is 0. So this is just ln 6 minus 0 is ln of 6. Okay, the integral from 0 to pi of x cosine x dx. I have a product, but those two factors, x and cosine x, are not related by derivative. One is not the derivative of the other. So that doesn't fully rule out u substitution, but it makes it less likely. So I'm going to start with by parts. So I have to choose a u and a dv and calculate du and v. All right, so U and dv, you typically choose them by choosing dv to be the most complicated piece of your integrand that you are still able to integrate. So I have to choose between x and cosine x. I'm going to make dv cosine x. Cosine x dx. Because that is more complicated than x, and I can still integrate it. And that means that u is just the x. Now I calculate du and v. So du is going to be the derivative of x, which is 1 dx. 1 dx. And then v is the antiderivative of cosine x, which is sine x. All right, so now I'm going to use the formula for by parts. The integral of u dv is equal to u times v minus the integral of v du. So u times v, that's x sine x, minus the integral of v du, so that's just sine x dx. So this is x sine x. The antiderivative of sine is negative cosine. So I have this negative sign here already, and then I'm going to have a negative cosine, so this becomes plus cosine x. Plus c. So that's the general antiderivative, but this is a definite integral. So I'm going to start a new line here. I'm not putting an equal sign in front because this is a separate calculation, period here, sentence ended. So the integral from 0 to pi of x cosine x dx is equal to the antiderivative of x cosine x, which we just calculated, and we're going to evaluate that from 0 to pi. So my antiderivative is x sine x plus cosine x. The c doesn't matter when you're doing the antiderivative, so I'm leaving it off here when you're using the fundamental theorem. So I'm evaluating from 0 to pi. Okay, so plug in pi, and we get pi sine pi plus cosine pi. And then subtract what you get when you plug in 0, which is 0 sine 0 plus cosine 0. Okay, so the sine of pi is 0. Sine of pi is 0. So let's see, I'm just going to do some of that here. Sine of pi is 0. The cosine of pi is negative 1. And then 0 times the sine of 0, that's 0 times 0. Cosine of 0 is 1. So this becomes pi times 0 is 0 plus the cosine of pi. So negative 1 minus 0 plus 1 is 1. Negative 1 minus 1 is negative 2.